In this video, we're going to focus on finding the average rate of change and the instantaneous rate of change. So let's say if we have the function f of x is equal to x raised to the third power. How can we calculate the average rate of change on the interval from 1 to 3? Now, what we need to realize is that the average rate of change represents the slope of the secant line. So here's the graph x cubed, or y is equal to x cubed. Y is the same as f of x. So at the point 1 and 3, which is these 2 points, the slope of the secant line is the average rate of change. The instantaneous rate of change is the slope of the tangent line. So let's say if we wanted to find the instantaneous rate of change at x equals 2, it would represent the slope of the tangent line. The tangent line is a line that touches the curve at one point. A secant line touches the curve at 2 points. Notice that you can approximate the slope of the tangent line by finding the slope of the secant line. If you want to find the slope of the tangent line at 2, you can estimate it using the slope of the secant line between 1 and 3, because 2 is right in the middle between 1 and 3. So for this function, go ahead and calculate the average rate of change. The average rate of change, which is the slope of the secant line, is the change in y divided by the change in x. Now in algebra, you've learned that the slope is basically y2 minus y1 divided by x2 minus x1. So the average rate of change, let's just put average. This is going to be f of b minus f of a. Keep in mind, f of x is the same thing as y, divided by b minus a, which is the change in the x values. So in calculus, this is the formula that you want to remember. That's the average rate of change. So for this particular problem, a is 1 and b is 3. So we're looking for f of 3 minus f of 1 divided by 3 minus 1. So if we plug in 3 into the equation, 3 to the third power is 27. 1 to the third, that's 1 times 1 times 1. That's simply 1. 3 minus 1 is 2. So it's 26 over 2, and so it's 13. That is the average rate of change in the interval between 1 to 3. So that is the slope of the secant line. Now, what is the instantaneous rate of change at x equals 2? The instantaneous rate of change is represented by f prime of 2. That's what it means. It's basically the derivative of the function at x equals 2, which represents the slope of the tangent line. But how can we estimate its value using the average rate of change equation? So if you want to estimate f prime of 2 using the average rate of change, you want the interval to be smaller. You want it to be closer to 2. So let's see what happens if we decrease the range from 1.9 to 2.1. Notice that 2 is in the middle between 1.9 and 2.1. But 1.9 and 2.1 is closer to 2 than 1 and 3. So f prime of 2 is approximately going to be f of 2.1 minus f of 1.9 divided by 2.1 minus 1.9. So what is f of 2.1? What's 2.1 raised to the third power? Okay, for this we need a calculator. It's going to be 9.261. And then 1.9 raised to the third power is about 6.859. 2.1 minus 1.9, that's 0.2. So 9.261 minus 6.859 divided by 0.2. So f prime of 2 is approximately 12.01, which is pretty close to 12. So notice that once we calculated the average rate of change from 1 to 3, it was about 13. But from 1.9 to 2.1, it's 12.01. 12 is not too far from 13. So the instantaneous rate of change is very close to 12. But now let's see what happens if we decrease the range. So let's make it even closer to 2. So let's calculate the average rate of change from 1.99 to 2.01. So this should be very, very close to the instantaneous rate of change at 2. So let's find out what f of 2.01 is, minus f of 1.99 divided by 2.01 minus 1.99. 2.01 raised to the third power. So I'm going to write the exact number. That is equal to 8.120601. And 1.99 raised to the third power, that's 7.880599. 2.01 minus 1.99, that's 0.02. Now if we type the whole thing in, 8.120601 minus 7.880599, you should get 0.24. And if you divide it by 0.02, your answer is about 12.0001. So as you can see, as you get closer to 2, the answer converged to 12. So we can say with good confidence that f prime of 2 is 12. That is the slope of the tangent line when x is equal to 2. So as you can see, when the interval, when a and b becomes very close to 12, the average rate of change approaches the instantaneous rate of change. So we can come up with an expression. F prime of x is equal to the limit as x approaches 0 for the change in y divided by the change in x. So this is the slope. That helps us to calculate the average rate of change. But the average rate of change becomes the instantaneous rate of change, or the derivative of the function, when delta x approaches 0. In the last example, when a was 1.99 and b was 2.01, delta x was very small. It was 0.02, which is pretty close to 0. And notice that when delta x was very small, the answer converged to 12. So this is how you could find the derivative of a function at a point. Now perhaps you've seen this formula. Limit as h approaches 0, f of x plus h minus f of x divided by h. So if you think about it, this equation means the exact same thing as this one. Delta y is the change in y, and we know that y represents f of x. So you could see the change in f of x. This is like f of b minus f of a, and b minus a is like h, which is delta x. So basically it's the slope equation, but as the denominator approaches 0. Here we have delta x approaching 0, and h approaches 0, which is the same as delta x. So you'll see this equation in your calculus course a lot. And then there's the alternate form of the derivative. The limit as x approaches a, f of x minus f of a over x minus a. This will give you f prime of a. So that's the slope of the tangent line. f prime of x is the derivative as a function, and that function gives you the slope at any point in the curve. F prime of a gives you the slope of the tangent line at some point x, but this gives you a function in terms of x, where if you plug in x, you could find the slope of the tangent line at any point. Now you need to know the easy way of finding the derivative and also how to use it with limits. So let's go over the power rule. What is the derivative of x to the fourth power? The derivative of x to the fourth power is 4x cubed. Now what is the derivative of x to the fifth power? The derivative, which is represented by f prime, is 5x to the fourth. Notice the pattern. Now what is the derivative of x to the sixth? This is going to be 6f to the fifth. Now what about the derivative of x to the seventh? What is the answer? This is 7x to the sixth power. And the derivative of x to the 8 is 8x to the seventh. Now what about the derivative of 5x to the fourth? So what if you have a constant in front? Ignore the constant for now and differentiate x to the fourth power. The process of finding the derivative is known as differentiation. If you differentiate x to the fourth, it's 4x cubed. And then you multiply the 5 and the 4. This will give you 20x cubed. So what is the derivative of 6x to the seventh power, 4x cubed, and 5x to the eighth power? Feel free to pause the video as you work on these examples. So for the next one, the derivative of x to the 7 is 7x to the 6, and then 6 times 7 is 42. The derivative of x cubed is 3x squared, and then 4 times 3 is 12. The derivative of x to the 8 is 8x to the 7, and 5 times 8 is 40, so it's 40x to the 7. Now what about the derivative of x, 5x, negative 4x, and 7x? The derivative of x to the first power is 1x to the 0. Anything raised to the 0 power is 1, so this whole thing is 1. So for this one, it's 5 times x to the first power, which becomes 5 times 1x to the 0, which is simply 5. So for negative 4x, it's simply negative 4. And for 7x, the derivative is simply 7. Now, what about the derivative of a constant like 8? The derivative of a constant is always 0. So the derivative of 5 is 0. The derivative of pi is 0. The derivative of e without the x is 0. Now let's understand why. We know the derivative of 7 is 0. 7 is the same as 7x to the 0. X to the 0 is 1. So if you use the power rule, if you move the 0 to the front, this is going to be 7, 0x to the negative 1. Anything times 0 is 0, so you'll end up getting 0. Now let's make sense of it. Let's say if we have the function y is equal to 3. So at 3 we have a horizontal line. Now remember, the derivative represents the slope. So if f of x is equal to 3, the derivative is 0. The derivative of a constant is 0. If you think about it, the slope of a horizontal line is equal to 0. So that makes sense. Now let's say if we have the function y is equal to 2x minus 5. To graph such a function, the y-intercept is negative 5. This is in y equals mx plus b form. The slope is the number in front of x, which is 2. So the rise over run is 2 over 1. If you go up 2 units from the first point, you need to go 1 to the right. So we have the point 1, negative 3. Up 2 over 1, we have the point 2, negative 1. And then up 2 over 1, 3, 1. And then we can connect these points with a line. So notice the slope of the line is always 2. So if f of x is 2x minus 5, what's f prime of x? The derivative of 2x is 2. In the last example, we said the derivative of 8x is 8, 5x is 5, pi x is pi, 4x is 4. So the derivative of 2x is 2. The derivative of a constant is 0. So notice that the derivative is always 2. At any point along this line, the slope is always 2. A straight line has a constant slope. Now let's go back to our old example where we said f of x is equal to x to the third power. So remember, we found the instantaneous rate of change, which was about 12. And that represents the slope of the tangent line at x equals 2. So here's another way you can find it. So if we calculate f prime of x, we need to move the 3 to the front. So it's going to be 3x, and then subtract this number by 1. So 3x squared. This is the derivative as a function. The derivative is a function that tells you the slope of the tangent line at any point x. And the slope of the tangent line is the instantaneous rate of change. So anytime you want to find the instantaneous rate of change, you can simply find the derivative of the function and plug in the x value. Now, if we want to find it at x equals 2, simply replace x with 2. 2 squared is 2 times 2, which is 4. 3 times 4 is 12. So notice this is the exact answer that we got when using the average rate of change to estimate the instantaneous rate of change. When x became small, or delta x, when the change in x became small, the average rate of change got very close to 12. Now let's use limits to get the same answer. So if you want to find f prime of x as a function, use this equation. The limit as h approaches 0, f of x plus h minus f of x divided by h. Now remember, we know the answer. F prime of x as a function is 3x squared when f of x is x cubed. So let's get the same answer using limits. So f of x is x cubed, which is this portion of the function. So we can put that here. This is going to be negative x cubed. Now f of x plus h, instead of writing x, we need to write x plus h. And then divided by h. So now, how can we simplify this expression? There's two things that we can do. We can either multiply x plus h 3 times, or we can factor using the difference of cubes. And I prefer to use that equation. The difference of cubes is a to the third minus b to the third is a minus b times a squared plus ab plus b squared. So x plus h is like a, and b is x. So what we have is the limit as h approaches 0, a minus b, which is x plus h, that's a, minus b, which is minus x. A squared is x plus h squared, plus ab, which is x plus h times x, plus b squared, which is x squared, divided by h. So notice that we can cancel the x variables. So now we have this expression, h times x plus h squared plus x plus h times x plus x squared divided by h. As soon as we get rid of the h on the bottom, we can now plug in the limit into the equation. So as h approaches 0, everywhere we see an h, we can replace it with 0 at this point. So once you plug in 0 for h, you don't need to write the limit expression anymore. So it's going to be x plus 0 squared plus x plus 0 times x plus x squared. X plus 0 is x, so what we have there is x squared. And then x plus 0 is also x, so that's x times x plus another x squared. So it's x squared plus x squared plus x squared, which is 3x squared, which we already had that answer. So we could see f prime of x is 3x squared by using the limit process. So that's how you can get the derivative as a function using limits. Now, how can we find f prime of 2 using limits? So keep in mind, we know that f prime of x is 3x squared. And f prime of 2, if you plug in 2, it's equal to 12. But how can we get this answer directly using limits? To do that, there's an equation that looks like this. F prime of a is equal to the limit as x approaches a, f of x minus f of a divided by x minus a. So this equation comes from the average rate of change equation, which is basically the slope of the secant line, f of b minus f of a over b minus a. The only difference is, instead of x, you have b. And notice as x approaches a, if x is very close to a, then x minus a is almost 0. And whenever the denominator is close to 0, the average rate of change becomes the instantaneous rate of change. So that's where this equation comes from. It's very similar to finding the slope of the secant line. So let's use it to find f prime of 2. So in this problem, a is equal to 2. Now we know f of x is x cubed. What is f of a? So if f of x is x cubed, what is the value of f of 2? F of 2 is going to be 2 to the third power, which is equal to 8. So let's put in 8. On the bottom, we have x minus a, which is x minus 2. So we need to factor x cubed minus 8 using the difference of cubes equation as we used it before. So in this problem, x is going to represent a, and b is going to be the cube root of 8, which is 2. So we have the limit as x approaches 2, a minus b, which is x minus 2, times a squared, which is x squared, ab, that's x times 2, or 2x, and b squared is 2 squared, which is 4, divided by x minus 2. So at this point, we can cancel x minus 2. Once we do that, we can replace 2 or plug in 2 into the equation. At that point, we no longer need to write the limit expression. So let's plug in 2. So it's going to be 2 squared plus 2 times 2 plus 4, which is 4 plus 4 plus 4. 4 plus 4 plus 4 3 times is the same as multiplying 4 by 3, since you're adding 4 3 times, and this equals 12, which is the slope of the tangent line at x equals 2. So that's how you can find the value of the derivative at a point. If you want to find the slope of the tangent line, you can use this form of the derivative equation. Now let's put everything together, all within one practice problem. So let's say f of x is equal to x squared plus 2x minus 3. So go ahead and find the average rate of change between 2 and 4. So the average rate of change is f of b minus f of a divided by b minus a. So this is f of 4 minus f of 2 over 4 minus 2. So let's calculate f of 4. Let's replace x with 4. So it's going to be 4 squared plus 2 times 4 minus 3. And if we plug in 2, it's 2 squared plus 2 times 2 minus 3 divided by 4 minus 2, which is 2. So 4 squared is 16, 2 times 4 is 8, minus 3. 2 squared is 4, but don't forget to distribute the negative sign. 2 times 2 is 4, but if you add the negative, it's negative 4. And then negative times negative 3, that's plus 3, divided by 2. So notice that the 3's cancel. Negative 3 plus 3 is 0. And 8 cancels with negative 4 and negative 4. So it's 16 divided by 2, which is 8. So this is the average rate of change of the interval between 2 and 4. Now, this represents the slope, not of the tangent line, but the slope of the secant line. So now let's calculate the instantaneous rate of change at x equals 3. So to do that, we need to find f prime of 3. The instantaneous rate of change is the slope of the tangent line at that point. But remember, the average rate of change is the slope of the secant line. So let's find the derivative. The derivative of x squared is 2x to the first power, which is simply 2x. The derivative of 2x is 2, and the derivative of a constant like negative 3 is 0. So f prime of x is 2x plus 2. F prime of 3 is going to be 2 times 3 plus 2, which turns out to be exactly 8. So this problem worked out nicely. The average rate of change turned out to be the instantaneous rate of change. Let's try another example. Let's say that f of x is equal to x to the fourth plus 5x. What is the average rate of change, or the slope of the secant line, in this interval from 1 to 4? So let's use the equation f of b minus f of a divided by b minus a. So that's going to be f of 4 minus f of 1 divided by 4 minus 1. F of 4, 4 raised to the 4 power. 4 times 4 is 16, times 4 is 64, times 4 is 256. And we have to plug in 4 into 5x. So 5 times 4 is 20. And f of 1, 1 to the 4th power is 1. 5 times 1 is 5. And on the bottom, 4 minus 1 is 3. So we have 256 plus 20, which is 276, minus 6. That's 270 divided by 3, which is 90. So the slope of the secant line is 90. That's the average rate of change. Now, how can we estimate the instantaneous rate of change, or the slope of the tangent line, at, let's say, 2? How can we do that? Well, first, let's find the exact answer. Let's find f prime of x. What is the derivative of x to the 4th power? This is going to be 4x cubed. The derivative of 5x is 5. So now if we plug in 2, it's going to be 2 to the third, which is 8, times 4, that's 32, plus 5, which is 37. So that's the easiest way to find the slope of the tangent line at x equals 2, or the instantaneous rate of change at that point. But now let's estimate that answer using the average rate of change equation. So let's estimate f prime of 2. Let's choose an interval between 1 and 3. If you want to estimate the instantaneous rate of change at 2, you want to pick two numbers where 2 is the middle. 2 is the midpoint of 1 and 3. So let's see what f of 3 minus f of 1 divided by 3 minus 1 is equivalent to. Now keep in mind, as the difference, as delta x, or the value of the denominator, as it becomes very close to 0, the average rate of change approaches the instantaneous rate of change. So since 1 is pretty much far from 3, our answer shouldn't be very accurate, but we're going to decrease the value of the denominator to approach the instantaneous rate of change, which we know to be 37. So what is f of 3? So 3 to the 4th power plus 5 times 3, and then minus f of 1, which is 1 to the 4th power plus 5 times 1, divided by 2. 3 to the 4th is 81. That's 3 times 3 times 3 times 3. 5 times 3 is 15. 81 plus 15 is 96. 1 and 5 is 6. 96 minus 6 is 90 divided by 2. This is 45, which is not very close to 37. So let's change the interval. Let's make it 1.9 and 2.1. So it's going to be f of 2.1 minus f of 1.9 divided by 2.1 minus 1.9. So 2 is still in between 1.9 and 2.1. But the difference now is not 2, it's 0.2. So the answer should be closer to 37. But let's see what it is. So we have 2.1 raised to the 4th power plus 5 times 2.1. That's f of 2.1 minus f of 1.9, which is 1.9 to the 4th power plus 5 times 1.9. And 2.1 minus 1.9 is 0.2. So 2.1 to the 4th power, if you type it in, that's 19.4481 plus 5 times 2.1. So that's going to be 29.9481 minus 1.9 to the 4th is 13.0321 plus 5 times 1.9. So that's going to be 22.5321 divided by 0.2. 29.9481 minus 22.5321, that's 7.416 divided by 0.2. This is about 37.08. So right now this is close enough to the instantaneous rate of change at 2, which is exactly 37. So as you can see, you can approximate the instantaneous rate of change using the average rate of change. Now you might be wondering, why do I need to know this? I mean, can I just find the derivative using the easy method, get the answer, and then I'm done? Well, the answer is yes. If you have the function, you can always do it the easy way. You don't have to do it this way. But sometimes you got to find the instantaneous rate of change and you don't have the function. Let's say if they give you a graph or a table of values and there's no function, there's no f of x, then you have to do it this way. So that's why it's important to be able to find the instantaneous rate of change using the average rate of change in the appropriate way. Now let's work on another example. Let's say f of x is x squared plus 3x minus 5. So what I want you to do is find the derivative and find the slope of the tangent line at x equals 3. And then use limits to find the derivative as a function and also the slope of the tangent line at x equals 3. So first let's do it the easy way. F prime of x is going to be equal to the derivative of x squared is 2x, for 3x is 3, and for a constant is 0. So that's the derivative as a function. To find the slope of the tangent line, or the instantaneous rate of change, plug in 3. 2 times 3 plus 3 is equal to 9. So now use limits to get this answer, the derivative as a function, and the slope of the tangent line. So to get the derivative as a function, it's going to be the limit as h approaches 0, f of x plus h minus f of x divided by h. So it's going to be x plus h squared plus 3 times x plus h minus 5. So that's f of x plus h minus f of x, which is simply the original function, divided by h. So how can we simplify this expression? What would you do? We need to FOIL x plus h squared. And let's not forget to rewrite the limit. So we have the limit as h approaches 0, x plus h times x plus h. And then let's distribute the 3 to x plus h. So it's going to be 3x plus 3h minus 5. And then we'll have to distribute the negative sign. So it's negative x squared minus 3x plus 5 divided by h. So 3x and negative 3x will cancel, and 5 and negative 5 will cancel as well. So now we have the limit as h approaches 0, x plus h times x plus h. So to FOIL, it's going to be x times x, which is x squared, and then x times h, and h times x, which is xh plus xh, or 2xh, and then h times h, which is h squared. And then we have 3h minus x squared divided by h. So now we can cancel x squared. And from what remains, let's factor out an h. So we have the limit as h approaches 0, h times 2x plus h plus 3. Now we can cancel h. So this is going to disappear. Now we have the limit as h approaches 0, 2x plus h plus 3. At this point, we can replace h with 0. So we get 2x plus 3, which is f prime of x. That's the answer that we had before. So that's how you could find the derivative of the function at any value of x. Now, since f prime of x was 2x plus 3, when we plug in 3, we saw that the slope of the tangent line was equal to 9. So let's see if we can get 9 using limits. So if you want to find the slope of the tangent line, if you want to get a number instead of a function that depends on x, use this form of the equation. It's the limit as x approaches a, f of x minus f of a divided by x minus a. So a is 3 in this example. So f prime of 3, which we know to be 9, is going to be the limit as x approaches 3, f of x minus f of 3 divided by x minus 3. F of x is going to be x squared plus 3x minus 5. So f of x is simply the original equation. And f of 3, we need to plug in 3, so it's going to be 3 squared plus 3 times 3 minus 5, all divided by x minus 3. So what we now have is x squared plus 3x minus 5. 3 squared is 9. 3 times 3 is 9. And let's distribute the negative sign. And then negative times negative 5 is positive 5. So at this point, we can cancel 5. So what we have left over, the limit as x approaches 3, x squared plus 3x, negative 9 minus 9 is 18, divided by x minus 3. Right now, we can't plug in 3 because we will get a 0 on the bottom. So we need to factor the numerator. So we have a trinomial with the leading coefficient of 1. What two numbers multiply to negative 18 and add to 3? This is going to be positive 6 and negative 3. 6 times negative 3 is negative 18, but 6 plus negative 3 is positive 3. So we could factor the expression like this. It's going to be x plus 6 times x minus 3 divided by x minus 3. If the leading coefficient is 1, you could simply write x plus 6 and x minus 3. So we can see that the x minus 3 expressions will cancel. So once we get rid of that factor, all we have left over is the limit as x approaches 3, x plus 6. So now we can replace x with 3. So it's going to be 3 plus 6, which is 9, which is the slope of the tangent line at x equals 3. So that's how you can use limits to find the slope of the tangent line. And now you know how to use limits to find the derivative of the function. And you also know how to do it easily. So now let's work on some examples where we have a table of values. So using this table, what is the average rate of change on the interval 1 to 3? What would you do to find it? So the average rate of change is f of 3 minus f of 1 divided by 3 minus 1. So it's going to be 11.6 minus 7.1 divided by 2. 11.6 minus 7.1, that's 4.5. Half of 4.5 is about 2.25. So that's the average rate of change on the interval from 1 to 3. Now let's say if you get a question that asks you, what is the slope of the secant line between the points 2 and 4? So to find the slope of the secant line, it's the same as finding the average rate of change. It's f of 4 minus f of 2 divided by 4 minus 2. F of 4 is 13.3, f of 2 is 8.9. So 13.3 minus 8.9, that's 4.4. If you divide it by 2, the average rate of change, or the slope of the secant line, is 2.2. Now, what would you do if you wanted to find the instantaneous rate of change at 4? So how can you find f prime of 4? To find f prime of 4, we can't do it directly. All we can do is approximate it using the average rate of change in the interval 3 to 5. Notice that 4 is the midpoint of 3 and 5. So it's going to be f of 5 minus f of 3 divided by 5 minus 3. F of 5 is 16.1, f of 3 is 11.6 divided by 2. 16.1 minus 11.6 is 4.5 divided by 2. So the instantaneous rate of change is approximately 2.25. It's not an exact answer. It's simply an approximation. Now, how can you approximate the slope of the tangent line at 1.5? This is the same as the instantaneous rate of change at 1.5. So we need to pick two numbers where 1.5 is in the middle of those two numbers. We can use 0 and 3, or better yet, 1 and 2. 1 and 2 is closer to 1.5 than 0 and 3. But let's do it both ways. Let's see what the answer is for 0 and 3 and then 1 and 2. So f of 3 minus f of 0 divided by 3 minus 0. F of 3 is about 11.6. F of 0 is 5. So 11.6 minus 5 divided by 3 is about 2.2. Now let's see what happens between 1 and 2. One and 2 is going to give us a better estimation. So f of 2 minus f of 1 divided by 2 minus 1. So it's 8.9 minus 7.1 divided by 1, which is about 1.8. So for this particular function, 1.8 is going to be a better estimate of the instantaneous rate of change than the other answer, since 1 and 2 is closer to 1.5. So if you're given a data table or even a graph, the best way to estimate the instantaneous rate of change or the slope of the tangent line is to use the average rate of change formula and try to get as close as possible to this number, and make sure this number is in between A and B. So that is it for this video. Thanks for watching and have a great day.